Hi everyone, this tutorial video is a continuation of trigonometry for CSEC Mathematics. We are going to look at the area of a triangle and two new rules called the sine rule and the cosine rule. Area of a triangle. So we have learned from lower form that to find the area of the triangle, we can use the formula area equal base by height divided by 2. But just to point out that the height in that formula is the perpendicular height of the triangle. But there will be cases where we would need to find the area of a triangle and the perpendicular height would not be known. Therefore, we have an alternative formula that we can use for finding the area of a triangle. So the area of a triangle can be calculated using the formula area equal a half AB sine C. And we can see that in our triangle, it's a non-right angle triangle, and we have, this is angle A, the side opposite would be the side A. For angle B, the side opposite that would be the side B, and for angle C, the side opposite that would be the side C. And this applies to all the triangles as we go on. And also to point out that in any formula, the common letters represent the lengths of the sides and the capital letters represent the angles. And also for this formula, the angle that is given, the two sides that's involved in the formula are the two sides that's adjacent to that angle. That means the two sides that are touching the angle. So if we have sine C, this is the angle that's given. The two sides that's touching that angle here would be A and B. So in any formula for area of a triangle using this, we would have the two sides that's adjacent to the angle that is given. Example, calculate the area of the triangle below to 1 decimal place. So area of a triangle equal a half AB sine C. So this is our angle and the two sides that are adjacent to that angle. So just substituting into our formula, we would have a half multiplied by 11 multiplied by 13 multiplied by sine 105 degrees. And just putting all of this into the calculator would give us 69 centimeters squared. And just another thing to point out would be that when we are working any of the trig functions in our calculator, it's important what mode the calculator is in because it does affect the answer. So for CSEC Mathematics, your calculators should be in degrees mode. Sine rule. The sine rule can be used for finding the length of an unknown side in a triangle or the size of an angle in a triangle that is not a right angle triangle, or it could also apply for right angle triangles. Now, in the past, when we had to find the length of a side or an angle in a right angle triangle, we used Pythagoras theorem and we used the trig ratios according to what we needed to find and what information was given. However, if we have triangles that are non-right angle triangles and we are required to find the length of a side or the size of an angle, then we can use this rule called the sine rule. And the sine rule involves two sides and two angles. And again, this can work for both right angle and non-right angle triangles, but it's specifically used for non-right angle triangles as it's simpler to use Pythagoras and trig ratios for the right angle triangles. So the sine rule looks like this. We have A over sine A equal B over sine B equals C over sine C. And from our triangle, if you look at it, it's very similar to the one that we did for area, where the angle A, the side opposite that is a side E. And for angle B, the side opposite that is side B. And for angle C, the side opposite that is side C. And at any point in time, only 2 out of the 3 parts here would be relevant for our calculations, as you would see in the examples. Example 1, find the value of x in each triangle below to 1 decimal place. So part 1, this is our angle x. We have triangle PQR. So this is angle P. This is a side opposite. So this would be the side P. Here is angle R. The side opposite that would be the side R. Now we do not have angle Q and we do not know the side opposite Q. So therefore, for our sine rule, the letters that are relevant, the sides that are relevant would be P and R. We cannot use Q because we don't have the information relevant for Q. So we will use P over sine P equal R over sine R. And just a reminder that the common letters represent the lengths of the sides and the capital letters represent the angles. So P would be the side P, which is 5.4. Sine P will be sine of x. R is the side opposite angle R, which is 6.7. And sine R will be sine of 95. So it gives us 5.4 over sine x equals 6.7 over sine 95. From this point, we are going to cross multiply, and that will give us 6.7 by sine x by equal 5.4 by sine 95. Making sine x the subject of the formula would give us 5.4 sine 95 over 6.7. I have chosen to leave it in this form, as when we work it out and we rounding off too much can affect the accuracy of our answer. So I'm leaving it in this form, and to find x we'll have to take the inverse. So x is equal to sine inverse of this. Putting it all into the calculator using brackets as well will give us x is equal to 53.4 degrees. And I am rounding off to 1 decimal place because the question specified to 1 decimal place. If it did not specify, then you could round it off to the nearest degree or however you like. But once it's specified in a question, you would need to follow the instruction. Part 2, find the value of x in this triangle. So looking at it, we can see that we have angle A and then the side opposite A. I have angle C involved and the side opposite C. We have nothing for B, no information. So therefore our sine rule in this case would involve A and C. Now for the sine rule, it doesn't matter whether we put the C on the left hand side and the A on the right hand side or vice versa. The A could be on the left and the C could be on the right, we would get the same result. So using C and A, we'll have C over sine C equal A over sine A. And getting our values from the diagram, the common letter C represents the side opposite angle C, which is 10. Sine C would be sine of x. Equal A, common A would be the side opposite that angle A, which is 15. And sine A would be sine of 60. From this point, we are going to cross multiply, which will give 15 sine x equal 10 by sine 60. We want to make x the subject of the formula. So for now, I'm just going to have sine x here, and on the right hand side, we'll have 10 sine 60 over 15. And to get x, we would take the inverse, which will give us 35.3 degrees to 1 decimal place. Example 2, find the length of the side AB to 1 decimal place. So this question is similar to the previous ones. The difference is, however, that we are finding the length of a side now instead of an angle. So we are given 2 angles and a side, and we need to find another side. So as stated earlier, the sine rule involves 2 angles and 2 sides. So we have the angle A, the side opposite that angle, which would be the side A. I have angle C, and I want to find the length of AB, which is this side, and this is the side that's opposite the angle C. So in our sine rule, we would have the letters A and C involved. So C over sine C is equal to A over sine A. Substituting our values, the common C is the side, which is AB, over sine 20, that's sine C, equal A, which is the side opposite angle A, that's 12, and sine of A would be sine 55. Cross multiplying would give us AB by sine 55 equal 12 by sine 20. And we want to make AB the subject of the formula, which would give us AB equal 12 sine 20 over sine 55, and that will give us 5.01 centimeters. And since the question specified to 1 decimal place, I would write that as 5.0 centimeters. Okay, now we are going to look at the cosine rule. The cosine rule can be used for finding the length of an unknown side or the size of an angle in a non-right angle triangle. So far the information is the same as sine rule. However, the difference is that the cosine rule involves 3 sides and 1 angle. So in comparison, the sine rule involved 2 sides and 2 angles. the cosine rule involves 3 sides and 1 angle. So it's also important moving forward that we know the difference, and we need to know which is the correct formula to use. And to figure out which is the correct formula, it's based on just this part here, the information that is given. So in a triangle, whether we want to find the length of a side and an angle, if we have 2 sides and 2 angles involved, it's the sine rule. But if we have 3 sides and 1 angle involved in the question, it's the cosine rule. So the cosine rule would be a squared equal b squared plus c squared minus 2bc cos a. And a, b, and c are variables. That means it can be any other letter. We can have p, q, and r, and any other letter given. So in this triangle, just as before, we see that if this is angle A, side A is opposite that. If this is angle B, side B is opposite that, and so on. For this formula, I would like to point out that the letter that I have on the left-hand side of the equation, which is A, corresponds to the angle in that cosine rule, so cos of A. So whatever letter or angle we have here corresponds to this side. And this in between would just be the other 2 sides in any order, B and C or C and B. So let's see how the cosine rule is used. Example 1, find the length of the side AB to 1 decimal place. So the side AB is this side, and we can see that this side is opposite the angle C. So that means we have the cosine rule, and even though I have triangle A, B, and C, because our angle is 100 degrees, our cosine rule letters would be written slightly different in terms of if this is the angle C, then here would also be C. This is the side C. Substituting those values, so c squared, that's the side we want to find, so that's AB squared. A squared, A is the side opposite angle A, which is 10. B squared is the side opposite angle B, which is 13. So we have 10 squared plus 13 squared minus, open bracket, 2a, which is 10, by b, which is 13, cos of c, and the angle c there is 100 degrees. Alright, so working that out, this part of it, 10 squared plus 13 squared, will give us 269. In brackets, the 2 by 10 by 13 will give us 260 by cos 100. It's important to work out brackets first. It's not 269 take away 260. We have to work out the brackets first and then subtract. So putting this into the calculator, 269 minus, open bracket, 260 cos 100, close bracket, this gives us 314.149. But notice that this is equivalent to AB squared. We just need the side AB. So therefore, AB would be the square root of that, which gives us 17.7 centimeters to 1 decimal place. Part 2, find the length of the side BC to 1 decimal place. So BC is the side opposite A. So this is the side A, angle A. Then this is the side C and the sides B. So we are going to use the cosine rule. Since we are looking at angle A, the letter that I have on the left hand side is also A. So A squared equal B squared plus C squared minus 2BC cos A. So A squared would be what we want to find. So I'm leaving that as it is. B squared is the side opposite B, so that's 7 squared. C squared would be the side opposite C. C is the side opposite angle C. So C squared would be 5 squared minus 2BC cos of A. So that's cos of 42 degrees. So 7 squared plus 5 squared gives us 74. And in the brackets, 2 by 7 by 5 will give us 70. And in the calculator, I'm putting in our values exactly as shown. 74 minus, open bracket, 70 cos 42, close bracket. So brackets there are important. And that gives us 21.97. And this is the value of A squared. To get A, I need to take the square root of that, which gives 4.7 centimeters. Example 2, find the size of an angle X to 1 decimal place. So our solution, from our diagram, we see that we have angle N, X is angle N, and the side opposite that is 20. So since the angle that is involved would be n, then in our cosine rule, on the right hand side we have cos of n, which means on the left hand side we'll have n squared. So n squared is equal to L squared plus m squared minus 2 lm cos of n. So substituting those values, let's just identify what those values would be. So angle n would be x. Our side n would be opposite n, angle n, which is 20. Then we have angle m, the side opposite that is 15, and 16 is the side L. So substituting those values, we would have 20 squared is equal to 16 squared plus 15 squared minus 2 by 16 by 15 cos of x. Simplifying, 20 squared would be 400, 16 squared is 256, 15 squared is 225 minus, and in brackets 2 by 16 by 15 gives 480, and this remains as cos x. And just simplifying these two values here, the 256 plus 225 to give the 481, and then I'm going to solve for x. So we are going to do that step by step. So now on the left hand side we'll have 400 minus 481 is equal to, and we are left with this part of it, minus 480 cos x. So this on the left hand side simplifies to give minus 81. So you'll have minus 81 divided by minus 480 is equal to cos x. So from this point, to solve for x, we'll need to take the inverse. So therefore, x is equal to cos inverse of 81 over 480 minus 81 over minus 480 is the same as 81 over 480, which is equal to 80.3 degrees to 1 decimal place. Part 2, find the size of angle A. So this is supposed to be angle A, it's not shown clearly on the diagram. So this is angle A. That means that in our cosine rule, we will have a squared on the left hand side. So a squared is equal to b squared plus c squared minus 2bc cos A. So a squared would be the side opposite angle A, which is 6.9 squared. B squared, B is the side opposite angle B, which is 7.3, and so that would be 7.3 squared. And C is the side opposite angle C, which is 5.2, so 5.2 squared. Minus 2 by 7.3 by 5.2 cos of A. So simplifying our values, we would have on the left hand side 47.61 equal, adding these values would give 80.33, and working out this in brackets, the 2 by 7.3 by 5.2 gives 75.92, and we have cos A. So I'm solving for A one step at a time. So we'll have 47.61 minus the 80.33 equal minus 75.92 cos A. That on the left hand side will simplify to give minus 32.72, and then this will give us cos A is equal to minus 32.72 over minus 75.92. So then A would be cos inverse of that, which will be 46.5 degrees. So just to recap, we have learned three main things in this tutorial. The first being finding the area of a triangle. Area is equal to a half AB sine C, where A and B are the two sides adjacent to the angle that is given in that triangle. The sine rule we have seen would be A over sine A equal B over sine B equal C over sine C, and only two out of these three parts are used, and the sine rule is used when in a question involves two sides and two angles. So whether we want to find the size of an angle or the length of a side based on the information that's given, if we have two sides and two angles involved, we need to use the sine rule. And for the cosine rule, it can also be used to find the length of a side or the size of an angle, but in this case the information that's given will involve three sides and one angle. So distinguishing whether to use the sine rule or the cosine rule in a question is determined by what information is given. So if we have two sides and two angles, we have to use the sine rule. And if we have three sides and one angle involved, we use the cosine rule. And also just to mention again that in any triangle, for area of a triangle, sine rule and cosine rule as seen in the diagram, that the side A is opposite angle A, side B is opposite the angle B, and so on. So this brings us to the end of the tutorial for trigonometry. Thank you for watching. If you have any questions, feel free to contact me. Thank you.